If you're studying for your AWS Solutions Architect certification, you know some of the AI and ML services can feel a little tricky. Well, today we're going to demystify one of the most powerful ones, Amazon Translate. We are going to break it all down from an architect's point of view so you can walk into that exam feeling confident. Let's dive right in. So imagine this classic exam question, right? You're tasked with architecting a new global application. Maybe it's a social media platform that's just buzzing with users from all over the world. Or maybe it's a live customer service chat. What is the single biggest hurdle you're going to face? It's the language barrier. How do you make sure someone in Tokyo can have a seamless conversation with a support agent in Paris? That is the exact problem that Amazon Translate is built to solve. Okay, first things first, let's get a really common misconception out of the way. Amazon Translate is not just another website you go to for translations. It is an API-first service. It's a building block, a component that you, as the architect, integrate directly into your applications. It's built to plug right into the rest of the AWS ecosystem. That, right there, is the key difference you gotta remember. And here is the official definition from AWS. Now, the key phrase I want you to focus on is neural machine translation. What does that really mean? Well, instead of just doing a simple word-for-word swap, it uses deep learning to understand the actual context and the nuance of a sentence. This means you get translations that sound much more natural, much more human. And because it's a fully managed service, you don't have to worry about a single server or managing any models. You just make an API call. So, here's our game plan for today. We're going to start with the basics, like choosing the right translation mode for your use case. Then we'll get into the fun stuff, customizing the translations to make them super accurate. After that, we'll look at some key architectural patterns for security and for cost, which is always important. We'll touch on monitoring, and then we'll wrap it all up with a cheat sheet of the most important takeaways for your exam. Sound good? All right, let's jump into the first major decision you'll need to make as an architect. It all comes down to one question. Do you need the translation right now, or can it wait a little bit? This choice between real-time and batch processing is fundamental, and it's going to shape your entire architecture. In this table here really breaks it down perfectly. On one hand, you have real-time or synchronous translation. This is for things like live chat, where you need an answer immediately. You make a call to the Translate Text API and boom, you get your translation right back. On the other hand, you have batch or asynchronous translation. This is your go-to when you're dealing with huge volumes of text, like translating an entire library of documents stored in S3. You kick off a job and you get the results a little later. Okay, this is a super important exam tip, so listen up. You have to know your limits. For a single real-time API request, you are capped at 10,000 bytes of text. If you have more than that, you have to either break it up into smaller chunks or, you guessed it, use a batch job instead. So burn that number into your brain, 10,000 bytes. Now this right here is a classic and very testable serverless pattern, and it's so elegant, isn't it? You just drop all your documents into an S3 input bucket, you make one API call to kick off the translation job, making sure you have the right IAM permissions, of course, and then you just let AWS handle everything else. When it's all done, your translated files are sitting there waiting for you in an output bucket. It's simple, it's scalable, and it's secure. Okay, so we know how to get translations, but how do we make sure they're the right translations? This is where customization comes in. It's all about fine-tuning the output to meet your specific business needs, whether that means protecting your brand's identity or matching a very particular style of communication. Amazon Translate gives us two really powerful tools to do this. First up is custom terminology. Think of this as your own personal dictionary or rulebook. It's perfect for making sure brand names, product models, or company jargon are always translated the way you want. The second tool is parallel data. This is less about specific words and more about the overall style and tone. You actually feed the service your own examples of high-quality translations to teach it your preferred way of speaking. This example from the AWS blog makes it crystal clear. You see, without any customization, a term like Amazon Family might get translated literally, which could be confusing. But with one simple entry in your custom terminology file, you guarantee that it's always translated correctly to Amazon Familial, preserving that brand identity no matter what. It's a small feature with a huge impact. And here's a great example of parallel data in action. Let's say your brand has a very casual, informal voice. By providing a training example that translates "how are you" to the informal "comment ça va," you're teaching the model your preferred style. Now, whenever you run a batch job using this parallel data, the translations will lean towards that more informal tone. This is how you can adapt the output to fit any context, from formal legal documents to casual social media posts. So we've got our translations, and they're accurate. Now let's talk about building a solid, well-architected solution around them. For any architect, two things are always top of mind: security and cost. So let's dig into how we handle those with Amazon Translate. When we talk about security, it really all comes down to network traffic. If your application servers are running inside of VPC, the last thing you want is for your API calls to Amazon Translate to travel over the public internet. The solution? An interface VPC endpoint. This essentially creates a private, secure tunnel from your VPC directly to the Translate service, all powered by AWS PrivateLink. Your traffic never ever leaves the AWS network. This is a massive security win and a critical concept for the exam. All right, now let's talk about saving some money. A lot of applications end up translating the same text over and over again. Why would you pay for that every single time? Well, with this brilliant caching pattern, you don't have to. When a request comes in, a Lambda function first checks a DynamoDB table. If the translation's already there, that's a cache hit. It returned it instantly without ever calling Translate. If it's not there, a cache miss, then it calls Translate, gets the result, and here's the magic part. It stores that new translation in DynamoDB for the next time. This simple serverless pattern can slash your costs and speed up your application at the same time. Okay, your application is designed, it's secure, it's cost-effective, and it's live. But our job as an architect is never truly done. Now we have to think about operations. How do we monitor performance? And how do we know if the service is reliable? The great thing is, Amazon Translates integrates directly with CloudWatch, giving you a bunch of useful metrics. The most important distinction to understand here is between user errors and system errors. Think of it this way. User errors, those are the 400x error codes, are basically your fault. Maybe you sent bad input or you have the wrong permissions. System errors, the 500x codes, are on AWS's side. The service itself had a problem. You have to monitor both to really understand the health of your application. And this brings us directly to the Service Level Agreement, or the SLA. This is a key concept. When AWS makes a promise about the uptime and availability of Amazon Translate, what they're actually talking about are those 5xx errors. So that system error metric we just saw in CloudWatch, that is your direct window into whether AWS is meeting its own SLA. Wow, we have covered a ton of ground. So let's boil it all down to the absolute essentials. These are the key facts and figures that you need to lock in for your certification exam. Think of this as your last-minute study guide for Amazon Translate. Let's drill this down. Real-time translation. Think small and fast with a 10,000 byte limit per request. Batch translation. Think massive, up to 5 gigabytes total. Custom terminology for brand names using relatively small 10 megabyte files, and parallel data for style, where you can use huge 5 gigabyte files for training. If you can remember these limits and their primary use cases, you are in fantastic shape for the exam. So I'll just leave you with this final thought. The next time you see an exam question or even a real-world project that involves building a global application, you've got this. You now have the tools and the architectural knowledge to make it secure, to make it cost-effective, and to make it accurate. You're ready to break down those language barriers. Now go nail that exam.